All right, this is the review for your mid-year test. Skip the first 13, so those are going to be for you to work on your own. As always, let me know if you have questions, if something in the video did not completely make sense. I'm not going to go through every single problem, but I'll start some of the problems, some of the issues I think you guys have had throughout the semester, kind of get you to that point, and leave the rest of the work for you to do. Make sure you're filling your cheat sheet as you go, as if you get to a problem that's kind of challenging. So start with 14. 14, we are not multiplying. That's the first thing we need to get through on 14. We are subtracting whatever comes out on the left side and whatever comes out on the right side. So even though you have the parentheses, it all matters about that sign in between the two parentheses. So I'm going to distribute a -1 first into that first parenthesis. So what was 2x plus 3 now becomes -2x minus 3. Notice I've just dropped the parentheses. I'm going to do the same thing on the right side. I'm going to distribute a -7. So -7 times 2x is -14x, and -7 times -3 is +21. And finally, we're just going to combine like terms. So -2x minus 14x is -16x. So those are like terms. Keep their signs. And then -3 plus 21 is a +18. 21 minus 3 is +18. So that's your answer. Make sure on the review, and particularly the test, you put your answers in the box. I don't know why I boxed it again. -16x plus 18 is your answer there. So that's a commonly missed question. 15 is not typically a commonly missed. This is multiplication because there is no sign between the parentheses. It's assumed to be multiplying. So you can do FOIL method, you can do box method, multiply, and combine any like terms on number 15. Again, pause if you want to go ahead and work that problem out, and then follow along with me on 16. 16, very similar, just a little bit longer than 15. You're going to multiply everything in that parenthesis first by 2x, and then you're going to multiply everything by a -5. So all together, we're going to multiply 6 times, and again, combine any like terms you have before you write your final answer in the box. Make sure you show all your work on the test as well. All right, so we've jumped ahead to the graphing section of this test. Guys, you can use your graphing calculator for this, or you can use the shortcuts we talked about last class. Either way works. It says 5 ordered pairs. I'm actually probably on the test going to make that 3 ordered pairs, but you do need to graph the vertex and then 1 point to the left of the vertex and 1 point to the right. So to get full credit, you need those 3 particular points. You have to have the vertex. If you're missing any one of these 3, it's all wrong. So make sure you have those things. If you need help using the calculator method, let me know. I'm going to show you the shortcut method that I showed in the last class. This number, so these graphs are V-shaped, and they start at the origin. This number on the outside, that is the vertical shift. If it's positive, it goes up. If it's negative, it goes down. So this shifts the vertex up 1 unit. The number on the inside, the formula is x minus something. So the value in there is actually just a +1. So that is actually going to shift us right 1 unit. Essentially does the opposite of what you think it would, because again, the formula, if you remember, this was the formula I gave you back in October. X minus h plus k. So essentially that is actually a +1, even though there's a negative sign in front of it. So we're going to shift the vertex up 1 unit, right 1 unit. The amplitude for this problem, or the slope, is 1. So we've got 2 points, 1 on either side. So your graph should look like that on number 18. Number 19, first thing you'll notice, there's nothing on the outside right here. So that means there's going to be no vertical shift. Means it stays on the origin. But we do have a horizontal shift. It is 3. So we're actually going to shift again to the right. Since that number is a positive 3, we're going to shift to the right 3 units. That's where our vertex goes. So shifting right 3 units, up 0 units. The amplitude is a negative 1/2. Since it's negative, that means the graph is going to be upside down. So to get our other 2 points, we're going to go down 1, right 2. The old slope formula, or down 1, left 2. So our graph's a little bit fatter. I would encourage you, if you're not going to use the calculator to come up with these points, at least put it in your calculator. Take a look at the sketch. And then finally, number 20. Number 20, there is a vertical shift. We're going down 7 units since it's a negative 7. So that's where our vertex will be. There is no horizontal shift since there's not a number on the inside of the absolute value. It's going to take me off the graph a little bit. Extend that just a little bit. So there's my vertex, down 7 units from the origin. Again, this number here tells me we are going up to the right 1 or up to the left 1. Since it's positive, it's got to be a smiley face graph. V-shaped smiley face graph. So there's your answer to 20. All right, 21. I believe we did problem like 21 and 22 last class. It is in log form. Anytime it's in log form and we want to solve it, we need to put it in exponential form. If the base is not given, it is assumed to be 10. So the shortcut to solve this problem is the base raised to the 3rd power equals negative 4x. So we're going to get 1,000 equals negative 4x. Divide both sides by negative 4. We get negative 250 as our answer. (22), the one addition to this problem that we need to make sure we remember before we use the shortcut and convert that to exponential form is it needs to be in standard log form. So to get in standard log form, there can't be a number in the front. So that's why we divide both sides by 7 first. So we're going to get log base 2, 22x equals 3. And now that one can be set up and solved just like 21. All right, 23. 23 is an exponential form. So we're going to put it in the other form to solve it. So we're going to put it in log form. But before we can do that, we need a log in the problem. So we're simply going to insert a log on the left side. And we're going to take the log of 10 to the x power. But whatever you do to one side of the equation, you have to do to the other. So I'm also going to take the log of 87. Again, I encourage you, those log properties we talked about last class, get to know those, write those on your cheat sheet. The third log property allows us to move the x, the exponent, to the front of log 10. And then to solve for x, our last step, divide both sides by the log of 10. So x is going to be approximately log 87 divided by log 10. Approximately 1.94. As long as you show all that work, if you have 1.93, that's fine. 1.9 would be okay. Put it in the box. All right, and finally, 24 on this page. We need to know those log properties again because before we can convert this to exponential form, we need a single logarithm. So this left side can be combined. The addition of logs converts to multiplication. So we can turn two logarithms into one simply by multiplying the x plus 4 and the x minus 4. I'll leave the rest for you, but of course you're going to multiply these out. These are conjugates, so some stuff should cancel when you multiply those two together and make that problem very solvable. I believe your answer will not be a nice, neat whole number. It'll be an irrational number. I believe it'll be the square root of some number that you need to make sure you simplify. But don't freak out if you get a weird answer. So I've changed my mind. I'll just go ahead and show you how to finish this one. X plus 4 times x minus 4 should ultimately get x squared minus 16. And then you convert it. 2 raised to the third power equals x squared minus 16. And then we can finish this. 2 to the third is 8. Add 16 to both sides. Take the square root of both sides. And then simplify that radical. Use a factor tree or use the method I showed you, whichever method works. So that's your final answer. That's what should go in the box for this particular question. All right, moving on to the next page. We're going to skip ahead to matrices because we didn't do many of these problems since after Christmas. So these are the two matrices I want you to multiply on 30. And remember, it is rows times column. So the pattern for multiplication is we're going to multiply 2, it's in the first position, by 8, it's in the first position of the other matrix, plus 6 times negative 4. So we calculate that, 2 times 8 plus 6 times negative 4. I believe that is negative 8. So negative 8 goes in the first box, the first position of your solution. Now we're going to multiply that first row times the second column. So that's 2 times 2 plus 6 times 5. All right, now we need to take the second row and multiply it by the first column. So that's negative 4 times 8 plus 3 times negative 4. And then lastly, I'm going to multiply the bottom row times the second column. I'll just do this all in one step. So negative 4 times 2 plus 3 times 5. I believe that is negative 44, negative 32, and then I believe this is 7. So make sure you're practicing these and not just copying the answers. If you're just copying the answers right now, make sure you practice these on your own a second time before the big test. Remember, no retakes for this test. All right, so the final matrix E problem I want to do is find the inverse of this matrix. All right, I'm going to erase this in a second. So this is the formula on how to find the inverse. So 1 over the determinant. So copy that down. I'm going to erase here in about 10 seconds. So if you need to pause it to copy that down. So that's how we'll start 31, find the determinant. So we're essentially going to subtract the cross products. 8 times -4 is -32, minus -3 times 2 is -6. So this actually becomes -26. That's our determinant. So we're going to take 1 over the determinant, and we are going to distribute it to the following terms. We flip the -4 and the 8. So we just flip-flopped those two. Then we take the opposite of the other two terms. That's in 2 becomes -2, -3 becomes +3. So distribute -1 over 26 times -4 is a +4 over 26, which can be reduced. Then we're going to multiply it by -2. That becomes a +2 over 26, which also can be reduced. So after we reduce, our final answer should be 2 over 13, 1 over 13. This is actually the inverse. It goes right in that box. All right, moving to the last page, I believe. So jumping ahead to number 36. Nope, not 36, 35. Simplify this one. This is not one we've done in class for about a week. So let's look at this one. To simplify, we need to eliminate all the radicals in the denominator. So to eliminate that radical, we need to multiply the bottom by its conjugate. And whatever you do to the bottom, you have to do to the top. So I'm going to ask you to pause it. I'm going to skip ahead and show the work for this problem momentarily. All right, so that would be the first step. That's what it would look like after we multiplied the top and the bottom. The bottom, since they're conjugates, those cancel. We're done with the radicals at the bottom. We're left with just 9 minus 6. On the top, we've got a whole lot of mismatching radicals, which none will combine or simplify. So I believe, yeah, that's our answer. That's our complete answer. The 3's here would not reduce. The only reason they wouldn't reduce is because there's no number in front of radical 30 that's divisible by 3. If there was, they all could reduce. All right, final problem, number 39. Let's look at this one. This, again, one we haven't looked at together. So it says factor that trinomial. So remember, the first thing you always look for is the greatest common factor. So 5, I think, is pretty obvious, the number that goes into all 3 terms. So we start with the 5 as the GCF. Then you look at the variables. They don't all have an x, so we can't factor out an x, but they all do have a y. So the GCF is 5y. So we're going to divide all those terms by 5y. So that leaves us with this answer. However, we can factor x squared minus x minus 20 a step further. So knowing that 5y is one of our factors, that's going to be part of our answer. I'm going to go over here. This is my answer box for this question since they didn't give us one. I'm going to put 5y. It's one of my factors. But now I need to factor x squared minus x minus 20. This is the box method for some of you that like the box method, where you take the first number and you multiply it by the last. And we're looking for two numbers that multiply together to give us negative 20. They have to add together to give us, in this case, a negative 1. So the factors of 20 are 1 and 20, 2 and 10, and 4 and 5. 4 and 5 are the only possible combination that can add together to give us negative 1. 4 minus 5 is negative 1. So essentially what we're going to do is we're going to rewrite x squared minus x minus 20 as x squared plus 4x minus 5x minus 20. And really, we can forget about the 5y. We've already put it in the answer box. It doesn't affect anything from here on out. We're going to factor this using the grouping method. So the GCF of the first group is an x. The GCF of the second group is a negative 5. So our factors are x minus 5 and x plus 4. So those are the other two factors. If we multiplied all three of these factors together, we would get the original problem. But leave it factored, and there's your answer to 39. Let me know if you have any questions. Just finish this before test day, which is Thursday. Good luck. Oh, and also, if you hear this part, you made it to the end of the video, you can write your name on a slip of paper, put today's date, hand it to me. The first 2 people to do this can get some extra credit.